Hello, in this lecture I would like to talk about multiplying special products. Now the fact is, this lecture is not really required. You're responsible for the material, but you learned how to do this in the previous section. You have all the skills to do this already, but it's worth noting certain patterns, so we're going to talk about it anyway. So for example, x plus 3 squared. You know that using your definition of exponents is x plus 3 times x plus 3. And we learned in the last section to multiply a binomial times a binomial, we can use the FOIL method. In other words, first, x times x is x squared. Outer, x times 3 is 3x. Inner, 3 times x is 3x. And then last, 3 times 3 is 9. And then I add like terms in the middle, and that gives me x squared plus 6x plus 9. But what this section wants you to realize is that any time you have a sum squared, it's going to follow this pattern right here of a squared plus 2ab plus b squared. So if you'll notice in our problem, our a is x and our b is 3, right? So if I use that formula, it says the first one squared. So in our problem, that's x. So it'd be x squared plus 2ab. Again, our a is x and our b is 3, so that means multiply a times b, so that's times 3x plus b squared, which is the last one squared, so plus 3 squared is 9. If I multiply that out, okay, notice I have an error written right here. I don't know if you were watching what I was writing, but right here, that needs to go. And this was x squared plus 2 times 3, in an x. Okay, so AB is x times 3, but I'm going to write it as 3x. There we go. So I add like terms, that gives me x squared plus 6x plus 9. Notice that's exactly what we got up here. Now again, you don't have to learn anything new in this section. What I really want you to realize is if you have x plus 3 squared, that's x plus 3 times x plus 3, and you can use the FOIL method. But if you want to use the binomial square pattern, that'll get you there. So notice it's square the first term, multiply the two terms together times 2, and then square the last term. So I have a few problems here where you can use that binomial square pattern, or you can just FOIL it out. X plus 5 squared is x plus 5 times x plus 5. We're going to do it both ways. You do x times x is x squared. This is the FOIL method. Plus 5x. Plus 5x, and 5 times 5 is 25, gives you x squared plus 10x plus 25. But now if I use the above formula up here, okay, then I have the first one squared, so that would be x squared because x is the first one. Then it says 2ab, which means multiply them together times 2, so plus 2 times 5x plus, and then you square the last one. 5 squared is 25, which still gives you x squared plus 10x plus 25. You don't have to do it both ways. I just want you to be familiar with this pattern in case it comes up, okay? When we start factoring, this pattern is going to be more important actually than right now when we're just multiplying or expanding. All right, if I look at the next problem, we have 3x plus 2 squared. I could look at that as 3x plus 2 times 3x plus 2. Then 3x times 3x is 9x squared. 3x times 2 is 6x. Plus another 6x, where we do 2 times 3x plus 2 times 2 is 4. That gives us 9x squared plus 12x plus 4. But now if we use the formula says square a, and the square of the first one squared, so that's going to be 9x squared. So I have to square the 3 and the x, right? Plus, then I'm supposed to multiply these together times 2. So it's going to be 2 times 3x times 2. And we'll write it down this time. Plus the last one squared, which is 4. So that gives us 9x squared plus 2 times 3 times 2. 2 times 3 is 6, times 2 is 12. Don't forget the x, plus 4. Notice we get exactly the same thing, so you get to pick your method. It really is up to you. X minus 4 squared is x minus 4 times x minus 4. If I use the FOIL method, x times x is x squared, that's first. Minus 4x, that's our last. Our inners, negative 4 times x is negative 4x, and our last, I think I said last a minute ago, didn't mean to. Negative 4 times negative 4 is plus 16, gives me x squared minus 8x plus 16. But instead, if I use the binomial square pattern, I'm supposed to square the first one. So the first one is x, squared is x squared. Then I'm supposed to multiply 2 times each of them multiplied together. So it's going to be plus 2 times x times negative 4. You got to take the negative with it. And then plus b squared, so plus negative 4 squared. Simplify, that's x squared minus 8x plus 16. And notice that's exactly what we got the other way. So this is entirely up to you which method you use. I really like the method we learned in the last section, just the FOIL method. I think it's easier. So I have 3 more problems here. So if I do 2x squared plus 3 times 2x squared plus 3, 2x squared times 2x squared is 4x to the 4th. 2x squared times 3 is 6x squared plus 6x squared plus 9, which would give me 4x to the 4th plus 12x squared plus 9. Or I use the pattern. I'm supposed to square the first one. So look at it this way. 2x squared squared plus 2 times the first one, 2x squared times the second one, plus the last one squared. There I just plugged right in the formula. Then when I square 2 and x squared, it's going to be 4x to the 4th, plus 2 times 2 is 4 times 3 is 12x squared plus 9. Notice I get exactly the same thing. Alright, 3y to the 3rd minus 1. So I have 3y to the 3rd minus 1 times 3y to the 3rd minus 1. 3y to the 3rd times 3y to the 3rd is 9y. Remember, add those exponents to the 6th. 3y to the 3rd times negative 1 is negative 3y to the 3rd. Negative 1 times 3y to the 3rd is negative 3y to the 3rd. Negative 1 times negative 1 is plus 1. So my final answer is 9y to the 6th minus 6y to the 3rd. When I add these like terms, plus 1. If I use my pattern, I square the first one. So 3y to the 3rd squared. I add 2 times the first one times the second one. So 2 times 3y to the 3rd times negative 1 plus the last one, which is negative 1 squared. When I square 3, that's 9. When I multiply power to a power right there, I get 6. And then 2 times 3 is 6 times negative 1 is negative 6y to the 3rd. And then plus negative 1 squared is plus 1. Finally, again, you do not have to do these both ways. I'm doing them both ways so you can see that you get the same result and you pick your favorite method. Xy squared minus 5 times xy squared minus 5. Xy squared times xy squared is x squared y to the 4th. Remember, add those exponents. Xy squared times negative 5 is negative 5 xy squared. Negative 5 times xy squared is negative 5 xy squared. Negative 5 times negative 5 is plus 25. Okay, when I add like terms, that gives me x squared y to the 4th minus 10xy squared plus 25. and leave myself room to use the pattern, but let's do it and save some space. If I square this first one, so I square the x, that's x squared. I square the y squared, that's y to the fourth. So that's x squared y to the fourth. Then I multiply these together times 2. So these multiplied together is negative 5xy squared times 2 would be negative 10xy squared. And then I square the last one, that's plus 25. So you see, either way, the problem with the binomial square pattern is only you have to have it memorized. And that's a disadvantage. I like a method that just seems natural, and writing it out twice, you just FOIL it out and that's it. But it's entirely up to you, and being able to recognize that pattern, there is value in that. Now here I have for you another binomial pattern, and it's not really the binomial square pattern because we're not squaring it, so let's don't call it that. It's just a pattern a plus b times a minus b. So we have x times x is x squared, x times negative 3 is minus 3x, 3 times x is plus 3x, and 3 times negative 3 is minus 9. Now what happens here when we add like terms, the minus 3x and the plus 3x cancel to give you x squared minus 9. This answer is called a difference of squares because that's a perfect square and that's a perfect square. Now again, you don't need this special method to multiply this out, but it helps to realize that if you have the same factor but one's plus and one's minus, those middle terms are going to cancel out every single time. Alright, here we go. Let's do a few more problems where we work with this binomial square pattern. So we have a plus b times a minus b is a squared minus b squared. Main thing is you recognize the pattern. Okay, but now we can use the FOIL method. X times x is x squared, x times 5 is 5x, negative 5 times x is negative 5x, negative 5 times positive 5 is negative 25. The middle terms cancel, give you x squared minus 25. Whereas here, you could FOIL it just like we did, or recognize, hey, these are exactly the same, but one's plus and one's minus. So what happens is I multiply this one times this one, I get x squared, and then this one times this one gives me 4y squared with a minus in the middle. It'll always have a minus in the middle. Again, here, you could FOIL it. Let's FOIL it. X squared times x squared is x to the fourth. X squared times 1 is plus x squared. Negative 1 times x squared is minus x squared. Negative 1 times plus 1 is minus 1. Those cancel. And you get x to the fourth minus 1. Or, you notice, hey, they match exactly. One's minus, one's plus. So that means I square the first one, put a minus in the middle, and square the last one. And I still get x to the fourth minus 1. Alright, last set of problems. Again, just to get you in the habit of taking a look at this, we could do 3x squared times 3x squared would be 9x to the add those exponents fourth. 3x squared times negative 4y to the third would be minus 3 times 4 is 12. X squared, y to the third. And then 4y to the third times 3x squared will be plus 12. I like my alphabetical order. X squared times first, y to the third. And then finally, last, 4y to the third times negative 4y to the third will be negative 16y to the sixth. These middle terms cancel. Now another way to look at it, I notice the pattern. They match exactly, but one's plus and one's minus. So I square the first one. 3x squared, all squared, would be 9x to the fourth. And then I square the last one. So 4y to the third squared will be minus 16y to the sixth. Remember, you add those exponents when you multiply the common base, or when you square, y to the third squared is y to the sixth. Either way you get there. Here, now check this out. This is tricky. These are not the same. I have a 3x first, a 2x second, a 2 is my constant, a 3 is my constant. I cannot use that formula here. I have to FOIL. 3x times 2x is 6x squared. 3x times 3 is 9x. Negative 2 times 2x is minus 4x, and negative 2 times 3 is minus 6. So this is a result of 6x squared. 9x minus 4x is plus 5x minus 6. So this doesn't even follow that pattern. You're right, one's minus, one's plus, but they don't match exactly. Now this one is our binomial square problem. 3k minus 5 times 3k minus 5. So here the middle terms don't cancel. 3k times 3k is 9k squared. 3k times negative 5 is minus 15k. Negative 5 times 3k is another minus 15k. Negative 5 times negative 5 is plus 25. So final result is 9k squared minus 30k, because there's two of them, plus 25. So that's our binomial square pattern there. This bottom one is the last pattern with the difference of squares answer, where you square the first one, you square the last one with a minus in the middle, and the middle terms cancel. Or you could FOIL this. Okay, let's use the pattern though. I square the first one, that's m squared. Minus is in the formula. I square the last one. 3/4 n times 3/4 n is going to give me 9/16, right? Because 3 times 3 is 9, 4 times 4 is 16, n squared. And we are finished with this section. So in this section, don't feel like you have to learn anything new. I think it's nice to recognize those patterns, but the skills that you learned in multiplying binomials together is plenty to do this section.